Hi, my name is Lukas Kosiński. I am the CEO of Safe Studio, custom software and hardware development company focused on Qt framework. Over the years, we have participated in many projects in the medical sector, helping clients with the GUI layer, logic, algorithms, and embedded software. Since 80% of our clients are in the medical sector, we prepare this Qt medical software course to answer as many questions as possible about Qt, our favorite framework, in the context of software development for medical devices. In this episode, we'll look at what can be done using Qt and what are its strengths and weaknesses. All of this in the context of the brutal requirements of the healthcare industry. If you have a moment, I encourage you to visit the Safe Studio website and our blog. I put all the links in the description. And also please hit the like button and subscribe to our channel. Have fun! So, let's start, guys, with the short introduction of Qt's capabilities in the context of what you can build using this tool. If you don't know Qt, you have to know that it is a cross-platform software development framework. It's based on C++. Actually, nowadays, I would say that it's not a framework anymore. I would rather call Qt a technology because under the same Qt name, there are a lot of other tools, like tools for quality assurance or for UI design. I personally like to call Qt the most cross-platform framework, as it's supported on wide range of operating systems and even wider set of hardware devices. It starts from even low-level microcontrollers. So, what kind of software can you develop using Qt? I will abstract here a bit from the features of the software, but rather focus on the purpose. First of all, let's start with the software in a medical device projects. I wrote an article available on our blog describing what's the difference between software in a medical device and software as a medical device. And to cut a long story short, software in a medical device project is usually integrated into the physical device. It requires hardware, robotics, electronics to perform its functions. As Qt supports wide range of embedded target boards, you can use it for both GUI and backend logic programming for software running in the physical device. For example, it can be a software serving as the spinal surgery system. I will show you some of our reference demo projects so you have an idea what SIMD device can be. So, here you see a demo demonstrating Qt running on custom Linux Yocto layer, showing Qt's 3D and UI programming capabilities. It also communicates with the laser components. Here, on the other hand, you can see the project of patients' vital parameters monitoring running on special medical tablet. It gets the data over the serial port from the sensor attached to it from UART port, and it then displays the data on some nice plots. Also, in context of software in medical devices projects, maybe that will be a new thing for you, but some companies, even the big ones, are using Windows and desktop Linux for their medical devices. They make the application full screen, so people have no idea what operating system is used in the device. Abstracting from whether it is a good choice or not, we need to know that Qt can also be used on desktop medical systems. So even if your medical device uses Windows or Linux, you can still use it as the base for your software project. Those of you who are familiar with the regulatory aspect of medical devices, you should know that the mobile app communicating with the physical device would in many cases be categorized also as part of the medical device project. Yeah, and thankfully Qt supports mobile platforms as well. Yeah, so Qt can be also used in the software as a medical device projects. which usually operate independently from the hardware. They fulfill the medical functions alone. And those projects are, for example, telemedicine software, self-diagnosis apps, therapeutic applications, and so on. And those types of software are often distributed as desktop or mobile apps, as they have to be made available for bigger groups of users. And as you already know, Qt supports desktop and mobile platforms. So you can handle software as medical devices projects with Qt. And just to make this list complete, I want to mention that Qt has a lot of classes and mechanisms supporting you in C++ development. So if your IoT device can run Qt and you want to make your life easier, then you can use Qt on your IoT device as well. Do you want to get some real examples of devices built using Qt? Let's take a look at case studies on Qt.io website. We can find that Dragar uses Qt for their respirators, Fresenius uses Qt for infusion pump software, and Clarius developed the portable ultrasound scanning system using Qt. I personally know that there are a lot of other big names using Qt, so you can trust me that Qt is a way to go for many in the industry. Okay, let's now discover the advantages of using Qt for medical software. Have in mind that a lot of those topics will be explained in more details in the next episodes. You can access those episodes right now. So, the very first thing, Qt is a complete software development framework. There are a lot of built-in modules that are already part of the framework. For example, there are 3D modules, advanced networking protocols, charts, and much more. Some of this offering I will explain later. For me, there was often the case that no dependency except Qt had to be used in the particular software project. And of course, it brings us several important advantages. First, it reduces the amount of regulatory work. In the reality of medical software, you have to document a lot. All frameworks, libraries, dependencies should be documented as SOUP, software of unknown provenance. The less you have, the less you have to verify and less to describe in your paperwork. And second thing is that with each additional external dependency, you risk that it won't be further developed by its authors. If you go with Qt, you make your project more resilient to the turbulence in those dependency streams. So using Qt, you can reduce the amount of work and secure more stability for your project. Another advantage of Qt is that using Qt, you can develop projects really fast. Maybe this sounds a bit general, and I won't back it up with facts to make this episode no longer than it already is. Of course, everyone says that about their tools, that they speed up the work. I don't work for the Qt company, for the company developing this framework. I am the CEO of other company, of software services company, and we might as well choose another framework. And Qt sometimes is not the answer to everything, but we still consciously choose it often. As a former programmer, I can tell you that Qt really speeds up the work. This is due to several things. First of all, there is Qt Quick module and QML language. They allow for a very natural declarative definition of UIs. There is multitude of modules, I already mentioned that, and there is ability to use design tools that even allow you to export a design from Figma to a generated QML file. Also, as Qt is cross-platform, and you decide to release the project on other platform, other device, then you can just use the code that you already have. Sometimes it requires, of course, some tweaks, some polishing, but often it just works like a charm. Another advantage of Qt is that many operating systems and hardware platforms are supported by Qt. And both those topics, choosing operating system and hardware, we'll get a separate episode with more details. However, you have to know that Qt supports all major desktop platforms, all major mobile platforms, embedded Linux, real-time operating systems, and WebAssembly. And in terms of embedded, it officially supports a wide range of targets starting from highly efficient MPUs to low-level microcontrollers. These cross-platform capabilities allow us to keep the flexibility on choosing the final target during the R&D phase. You can port code to other platforms whenever you want. You can reuse code for other projects. You realize not only within the same system, but also within the entire organization. With Qt, you can keep the technology stack smaller. And just to give you an example of low technology stack, recently we started working for a company that requires a mobile app, website, embedded GUI, and desktop app. So they save a lot actually, because Scythe develops shared modules and libraries for them, which are used across all those apps. This advantage is often called low total cost of ownership, as you need fewer resources and less time to make your project real. I don't want to sound like someone immune to news, but in quality industries, which certainly include the medical industry, choosing solutions that have been on the market for a long time and have a well-established brand is essential. After the clinic purchases the device, it is used for years, if not dozens of years. So we don't want to base our software on a framework that will disappear or change drastically in a short time. Of course, we never know what will happen to a particular technology, but I personally, I am a big fan of the choose boring technology theory. It does not mean that Qt is boring. It just tells us to choose mature technologies over trendy and shiny ones. The next thing are certifications. I'm not going to read all of the certifications that Qt Group, the company behind the framework, and its products have. You see some of that on the slides, and yes, certifications are proofs of the quality management system in place and that products are developed with care. If you are familiar with the 62304 for medical projects, you know that no one can tell you exactly what you should do and how to do it in terms of medical device, medical software documentation. It rather tells you to describe your processes and explain yourself how you are mitigating risks in your project. This includes verifying third-party software, like the dependencies that you used. Yeah, and here one aspect cannot be ignored. When developing medical projects, you need to ensure traceability. Qt has a very restrictive yet open development process with several steps of static analyzing, reviewing, and unit tests. You can track and verify all of that on your own. There is a feature freeze approximately 13 weeks before a targeted release date. And it is for both major and minor Qt releases. So in this aspect, Qt fulfills the market standard requirement of traceability. It's really important for medical software. Qt also takes care of cybersecurity issues. Code-wise, it allows the implementation of encrypted communication and the use of network security protocols. And of course, cybersecurity issues are being addressed already at the development and quality assurance level. Just imagine that about 20,000 test suits are automatically fired for a single test configuration, for the Qt source code. In addition, Qt code is subjected to static code analysis. It's also important from medical standards. Qt has dedicated cybersecurity teams, and as far as I know, they have internal processes where they start working on reported vulnerabilities within a day. Therefore, I think the cybersecurity issue is also a Qt advantage. This could be mentioned while talking about Qt's enormous content, but it's a big thing, so I wanted to make a separate point about this. Also, by extra solutions, I don't mean parts of Qt software framework. You have to know that Qt offerings also include the design and quality assurance tools. To my mind, especially the Q&A tools deserve a bit of your attention. Using them, you can cover the needs for static code analysis and unit tests, which are both very often included in the regulatory documentation in form of reports. Therefore, we will in future have a separate episode about Q&A tools, but as you see, it's definitely helping people deal with assuring quality for their projects. Wow, I'm not Qt's fanboy. I always try to evaluate this framework objectively, but it's the reality of medical devices development using Qt. There are a lot of reasons to go with Qt for this sector, but of course, Qt is not a way to go in all situations. Let's talk about weak points of Qt. First of all, if you target really low-level devices like, for example, ESP microcontrollers, there are even more lightweight solutions than Qt. Also, limited controllers, microcontrollers can be handled with Qt only by using Qt for MCU offering, which is only available in the Qt's commercial license, so not all organizations can afford this. The next disadvantage of Qt is that it is not that popular solution as C# or web framework that can be also used for medical devices development in many sectors. That's probably caused by the fact that Qt and C++ have steeper learning curve compared to the other technologies. There are official Qt bindings to Python and unofficial to other languages. And as I know, there is some ongoing work to allow using the power of Qt with other programming languages, but we have to wait for that a little bit. For sure, C++ will stay a core programming language for Qt for a long time, which is not necessarily bad, but for sure the number of skilled Qt developers is limited. Yeah, and that's why you can consider contacting us to support you in the project. Qt Group attempts to solve both this issue and the fact that there are not that many skilled software engineers by Qt Academy initiatives. It is the place where you can find the learning materials. Qt also organize competitions for university students, so in truth, they do a good job to solve those issues. Yeah, and the last weakness that I can think about for now is the fact that I would say that Qt offering is a bit overwhelming. You might have such an impression already watching this video that causes a bit of confusion for the newcomers. There is also a licensing model which is even more confusing and people don't get it. I think that it's simple, but it's confusing at the first glance. Yeah, so those are the disadvantages, weaknesses of Qt to my mind. Okay, guys, as you just have seen, there are a lot of reasons to go with Qt for medical software development. If you want to see what factors should influence the choice of software framework for your project, have a look at our blog post titled How to Choose the Right Technology for Healthcare Software Development. Link is in the description. Remember to visit our website, like this video and subscribe to our channel. In the next episode, we will talk more about choosing a hardware platform for your project and what Qt has to offer in detail in this aspect. See you there.